Okay, so we're starting to get the idea, right? The velocities are different, and the drift speed in wire number 2, the thinner wire, has got to be bigger than the drift speed in wire number 1. So let's just go back to this. We said that in the steady state, the current flowing, which way is the current flowing, first of all? The electrons are moving from the negative to the positive, so the electrons are moving that way, right? So the electrons moving, number of electrons per second flowing out of wire 2 has got to be equal to the number of electrons per second flowing into wire 1. So we can say I1 is equal to I2. Plug in our relationship between electron current and the drift speed, and we have N1 A1 V1 is equal to N2 A2 V2, right? And the electron densities are the same, right, if it's the same material. But the areas aren't, okay? So we have this inverse relationship, right? If the area of 1 is larger, then its speed has to be smaller. If the area of 2 is smaller, then V2 has to be larger. So V2, or V1 is less than V2, or V2 greater than V1. And sometimes it's helpful to think about an analogy with a water pipe. The water analogy sometimes breaks down with circuits, so you don't want to get too dependent on it. But in this case, it's kind of nice, because if you think about just, you have a flow of water in a pipe, and in this case, you just have a fatter pipe, right? So to get the same amount of water flowing past every second, same number of water molecules, they don't have to flow as fast. Whereas in this case, if you have a thinner pipe, right, they have to be moving quicker so that you get the same volume of water to move past every second. It's the same idea here, right? Same idea here. And you can kind of see that with a water nozzle. If you crank if you make it really small, you get a high velocity stream of water, right? So same type of situation here, okay? Just kind of motion of a continuous fluid. It's almost like a fluid.